Hey everyone, Mr. Armitage here. In this video, we're going to be doing another Check Your Understanding, this time on the assignment handed out on March 20th, although we did the Check Your Understanding today. Well, today is when I'm recording it, March 21st. Okay. So the original assignment was about juniors versus seniors going to prom, right? Confidence interval for two proportions, right? P1 minus P2. Okay, we're going to go through the Check Your Understanding of this one. Okay, so in a social study, a random sample of 150 teachers were selected and an independent random sample of 100 nurses were selected. Each person was asked if they currently have a second job. The results showed that 48 of the 150 teachers and 21 of the 100 nurses had a second job. Construct and interpret a 95% confidence interval for the difference in proportion of all teachers and nurses that have a second job. Okay, so it's a lot there. And we're going through the 4-step process, okay? But it's not too bad. All right, so let's go ahead and start with our parameters, okay? We have two parameters, or two-ish, right? P1, okay? Actually, let's use some colors, shall we? P1, okay? Which is the proportion of teachers, okay? With a second job. Okay, sorry, I don't want to spend forever writing this. Okay. We'll do green for P2, okay, which will be the proportion of nurses, okay, with that second job, okay. Now, the thing that we are finding, right, P1 minus P2, okay, P1 minus P2. So we want the difference between these, okay, which is separate, related, but distinct from P1 hat. Okay? P1 is the proportion for the population. P1 hat is the proportion from the sample. Okay? So we had 48 out of 150 teachers, which I think was a whole number. Yeah. 0.32. Okay. And then P2, right, proportion of nurses. So that means P2 hat will be the sample proportion of nurses. 21 out of 100. And you don't need a calculator for that one, 0.21. There we go. Okay. Confidence level, okay, 95%. Okay. Don't jump ahead. Right now, it doesn't hurt to say like, oh yeah, Z is going to be 1.96, okay? But that will come back to us later because we do, or we should, name the procedure first, okay? So this is a 2 proportion Z interval, okay? You'll see why soon enough, okay? Or, well, you'll see why we don't want to give the critical value right away after seeing the 95% soon enough. Not in this assignment, in the next coming weeks. Okay, check conditions. So first thing, are they random and independent? Okay, so are the samples random and independent? Right? Random sample of 150 and an independent random sample of 100 nurses, right? Independent of the teachers. So, yep, got that there. Okay. Second condition, right, is the 10% condition. Right. So we are looking at blue, N1 times P1 hat Oh, sorry, no, that's not the right one. I'd make a very common mistake. Okay, we're looking at, let me move my tablet a little bit. Okay, there we are. Okay, no, we're looking at is N1 less than 10% of, I guess, big N1. Okay, to put it short, right, is the number of teachers 150 less than or equal to 10% of all teachers? And the answer, I think, pretty clearly is yes. Okay. Similarly, for nurses, right? Only this time I'm not going to write out the N2. Okay, is 100 less than 10% of all nurses, right? Now you should know, right? There are a lot of nurses and there are a lot of teachers in the country, so yeah, that's also true. So finally, large counts. Okay. So first, we have to know if the number of successes is greater than 10. Okay, so in this case, yeah, 48 is greater than 10. Okay, that could be n 150 times 0.32, but that would give us 48. Okay, similarly, right, I should have known that. Okay, 102 is also bigger than 10, which would have been 150 times 1 minus 0.32. So 150 times 0.68. Okay, that would get us 102. So those are good. Let's check the nurses. Okay, so let's see, we had 21 bigger than 10, right? Okay. So we had 21 of them with a second job, and out of 100, that would mean that there are 79 without a second job. Okay. And these are also bigger than 10. So we have met all of our conditions. Let's go ahead and do our formula. Okay. So remember, the general formula is always the point estimate plus and minus the margin of error. Always. Okay. Now the specific formula here, okay, is going to be p1 hat minus p2 hat. I'm just going to change some colors. Okay. Plus or minus. So that's our point estimate, p1 hat minus p2 hat. So 0.32 minus 0.21. Okay. Plus or minus, right, z star. Okay, because we're doing a z interval, so that's going to be z star times the square root of our two variances added together. I don't know if you heard, AC just turned on here. Okay. So p1 hat times 1 minus p1 hat over n1 plus p2 hat times 1 minus p2 hat over n2. Okay. Now you could go through, plug in all the numbers here, right? 0.32 minus 0.21 plus or minus 1.96 for z star times the square root of, okay, 0.32 times 1 minus 0.32 divided by 150 plus 0.21 times 1 minus 0.21 divided by 100. And do that all in your calculator and take a while to type it in. Okay. Or we could do this. the 2-prop z interval. Okay, I'm going to take a couple things that actually I'm not going to put right here. I'm going to put below it. Okay, kind of on the answer because we're going to get the answer out of it. Okay, and we'll show you on the overhead. 2-prop z int. Okay, x1, n1, x2, n2, and the confidence level. I almost ran out of space. Great. So now, you got to identify the parts. Okay, right? N1 was 150 and N2 was 100. Now the X's are our successes. So success, right? Number of teachers with a second job. So in this case, it is 48. In this case, it is, right, 21. Okay. There we go. Okay. And we can put that into our calculator. Right. Now I'm going to show. Oh, wait, there we go. Okay. I'm going to show on both of our calculators that we use in class. Okay. We'll let that one boot up. Do the TI-80 first. Okay, we go to Stat, Tests, and we scroll down to line B, okay, 2-prop z interval. Okay, x1 was 48, n1 was 150, x2 was 21, n2 was 100, and our confidence level was 0.95, which I forgot to put on here. Thank you all for letting me know. 0.95, there we go. There we go. Calculate. Okay, it gave us that. Okay. All right, -4 and 0.2193. Okay, we talked about scientific notation before. Okay, but let's see what it looks like on the n-spire. Okay, so we go to menu because this is not 7e -4. This is an actual number. Okay. Statistics. Okay. Confidence intervals. Notice I'm not hitting the center. I'm going off to the side. Okay. And then line 6, 2-prop z interval. Okay. And sorry, x1, right? 48. N1, 150, X2, 21, N2, 100, C level, 95, enter. Okay. So you can see everything we have here. See, now it is 0.000, maybe you can see it on the screen, I don't know, 0.00074704. Okay, because remember, this is really 7 times 10 to the -4th. So that's going to be 0.1234. So 4 decimal places move to the left. So 0.0007 and obviously 0.2193. Okay. So our conclusion, right, we would write out, we are 95% confident. Yeah, okay, I have space. Okay. Go. Okay. 95% confident that, sorry, broke out in cursive there, that the interval from 0.0007 to, okay, good, you can still see, 0.2193, okay, captures the true difference of proportions of teachers and nurses. Sorry, I am abbreviating incredibly hard right now, just because we can't take forever writing this, right? True difference of proportions of teachers and nurses with second jobs, Okay, now we might notice, right, these are both positive, okay, which means that our entire interval is positive, which, if you remember from our important ideas, also tells us that we are dealing with a situation where P1, proportion of teachers with the second job, is greater, okay? So P1 is greater than P2. Which tells us that I'm not going to write it out, but right, you might want to, okay, that the proportion of teachers who have a second job is higher than the proportion of nurses with a second job, statistically speaking, right? We have convincing evidence that the proportion of teachers with a second job is higher than the proportion of nurses with a second job. Okay? So that's all for our Check Your Understanding for this assignment. Have a great day.